Hello everyone, welcome to my programming club. Today we will be solving another daily Leetcode problem, and the problem's name is largest divisible subset. So the problem statement goes like this: given a set of distinct positive integers called nums, return the largest subset answer such that each pair in that subset follows the following constraints. Okay, so let's say there is a subset that is given to you, okay, and it is having some elements. Let's say you pick a pair of elements from this subset a colon b. Now either of these conditions should hold true for this particular subset. Either b should be able to divide a completely, or a should be able to divide b completely. Okay, so either of these conditions should hold true for every pair of elements in a subset. Okay, and we have to return largest subset among all the subsets that are following this condition. Okay, and if there are multiple answers, we are told to return any of them. And let's see the constraints. So the number of elements in the nums array are of order 10 raised to power 3, and each element is ranging from 1 to 2 into 10 raised to power 9. Okay, and it is mentioned that all elements in the nums array that will be given to you will be unique. Okay, or array or set, whatever you may want to call it. So let's see how we will be solving this particular problem. First of all, we will be considering a brute force approach. This approach can be to generate all possible subsets. Okay, and after generating all possible subsets, we will filter out the valid subsets. Okay, subsets following the given condition. Okay, then among those valid subsets, we will be taking maximum length subset. Okay, so even to generate all possible subsets, let's say you are given nums array or nums set of size n, you will be required to 2 raised to power n operations, order of 2 raised to power n operations. Why is it so? Let's say these are the elements of subset, then every element is having two options: either it will be included in the largest subset, or it will not be included. So in all total 2 into 2 into 2 these operations will be there, and it will be repeated n number of times, and will be the length of nums array that is given to you. Okay, so and n here, as you can see in the constraints also, is of order 10 raised to power 3. So the number of operations that this brute force approach will be requiring will be of order of 2 raised to power 1000, which is a pretty huge number as compared to order of 10 raised to power 8 operations. So if you ask what this 10 raised to power 8 operations is all about, this is nothing but a operation limit. Okay, if the number of operations required by a solution to solve a particular problem exceeds or become equal to this operation limit, then you may get a TLE and your solution will not be accepted. So time limit exceeded it is, and your solution will not be accepted. So we need to optimize this brute force approach. Let's see how we can optimize this brute force approach. What we can do is, let's say a colon b is a pair, and a is dividing b completely. Okay, this is holding true. It is a pair belonging to a subset. So what you can do, you can take a directed edge from A to B. You can call that B is a multiple of A. Okay, so this represents B is a multiple of A. So if you take an example, let's say this example we take 1, 2 and 3 it was. Okay, so 1 can divide 2 and 3 both, but 2 and 3 cannot divide anything. So you can say that 2 is a multiple of 1 and 3 is a multiple of 1. Okay, now what you are required to return in answer is whatever starting from the number that is not a multiple of anyone. Okay, so 1 is not multiple of any number, so we'll start from here and ending till we are at the very end of the graph. Then we will see what will be the maximum length branch there or maximum length chain there. So you can say 1 and 2 is forming a chain and 1 and 3 is also forming a chain. So both of these are of length 2 only. Okay, so you can return either of them. So if you see the explanation also, 1 3 is also a accepted answer. So what we can do, we can start from the node which is not multiple of any node, and we can just run a DFS here, depth first search. Those of you who are new to DFS, I'll be providing a link explaining what DFS is. Okay, article will be there which will be explaining what DFS is. Basically starting from a source node, we go till the very end of the graph. Okay, and then after that we backtrack and explore other options. Okay, so let's say you start from 1 and then you decide to go in this direction, then you will go till the very end, and once you are not able to proceed further, you will come back and see what other options are there. Then 1 was also connected to 3, then we will explore this path completely. Okay, before exploring any other path. So this is in nutshell what DFS is. Anyhow, this will lead us to a little problem. What it can be, let's say, let me take another slide. This is the graph. Okay, and 3 can divide 9, also 9 can divide 27. Now this 3 can divide 27 also. Okay, and let's say after 27 it was 81. Now you can see that 3 can divide 81 also. Okay, and 9 can also divide 81. Okay, so if you see if we want to form a chain, it can be something like this: 9, 27 and 81. Okay, it can also be like this: 1, 3, 9, and then after 9 you can just jump to 81. Okay, it can also be like this, that you can jump to 81 after 3. Okay, so there are repetitions here. What repetitions are here? These are different chains. Let's call this chain 1. Okay, this is chain 2, this is chain 3. So if you see in all these 3 chains, this part is repeated, and this part is repeated in about 2 chains. Okay, so for this repeated part you will be doing recalculations or recomputations again and again, and these recomputations will be so large that your number of operations will not be just limited to 10 raised to power 8 operations. Okay, so and you will not be getting accepted solution here because of this extra work that is generating because of this overlapping subproblems. Okay, extra work due to overlapping subproblems. Okay, so we need to optimize this particular approach, and this approach was directed graph plus DFS. Okay, and we were starting from the node which was not having any numbers that you can say any factors. Okay, basically, or if you want, you can say it is not a multiple of any number. Okay, so we were starting from those numbers only. So this approach needs to be optimized. Optimization required. Okay, so how will we, you know, making optimizations? What we can do, if somehow we are able to store, let's say, what will be the chain after 27. Okay, so let's say 27 is storing a chain which is something like this. Also, let's say 9 is also storing a chain which is 9, 27 and 81. It is the longest chain that is possible starting from this node as a source node. Okay, longest chain possible starting from current node to the very end. Okay, then whenever these subproblems will reoccur, we will simply return the answer that is stored in every node. Okay, answer is what? It is the chain that is longest possible chain starting from this node. If you consider this one as the source, then two length 2 chain can be there. For 81 it can be only one element, 81 only. Okay, so we can somehow store these chains, and whenever a subproblem is repeated, we'll simply return that stored result instead of recalculating or doing extra work there. So we can avoid extra work by this method. Okay, so this problem was following a particular property which was overlapping subproblems. Okay, I hope it is now clear to you what overlapping subproblems are. Okay, if you are still not clear, I will also be providing a link of an article describing what overlapping subproblems are in a particular problem. Other than that, what we can observe in this particular problem is, if let's say you want to know what will be the longest chain that can be there, which is possible starting from 3 as source node. Okay, then you can be finding all the multiples of 3 that are there. Okay, these are multiples of 3, and you can pick the multiple which is having largest chain that is possible. Okay, so if you pick the multiples of 3, 9 was also a multiple of 3, 27 was also multiple, and 81 was also a multiple. Okay, but 81 is having only a chain of length 1, and 27 was having a chain of length 2, and 9 was having a chain of length 3. So we will definitely pick 9 because it was having the longest chain that was possible. So what we will do, we'll just simply add 3 to this chain, longest chain, among the multiples of 3 that were there. Okay, so there can be multiples of 3, can have their own chains. Okay, so we'll be picking maximum chain that is possible. Okay, max chain from multiples of 3, and we'll link 3 with max chain that we will find. So you can link 3 with this chain 9, 27 and 81. So 3, 9, 27 and 81 can be a chain. Okay. Similarly, if you see for one was having 2 multiples. Okay, for 1, 9 will also be a multiple. Okay, and 27 will also be a multiple, and similarly this 81 also be a multiple. So among all these multiples, which multiple is having maximum length chain? Okay, so its length was 4 and 2 was having only a chain of length 1. So indeed 3 is the multiple which is having maximum length chain. So we'll pick 3, 4, 1 and we'll add 1 to the chain. So what we'll do, 1, 3, 9, 27, 81. Instead of recalculating every link that was there from 1, we'll simply see that whether this particular subproblem have occurred before or not, and we'll simply be using that. So you can see here from this particular observation that solution of, let me change the color, solution of bigger subproblems can be derived from solution of smaller subproblems, or combining the solution of smaller subproblems. Okay. So there can be a bigger subproblem and there can be smaller solutions of smaller subproblems. They can be combined to form the solution of bigger one. So this particular property is called optimal substructure, second property. Okay. So those of you who are new to this particular property also, and you are still not able to understand from the explanation I have just provided, you can visit the link that I'll be providing you for an article that will be describing what optimal substructure is. And when these two properties are followed by a problem, then you can apply a optimization technique here, which is dynamic programming. Okay. In dynamic programming, what we do is we will store results for all states that are possible, that are there. Okay, what I mean by states is nothing but different instances when your recursion will be taking source 3 sometimes, and it will be taking 27. So these are nothing but states. All these nodes are states. Okay, 3 is also a state, 9 is also a state, 27, 81, so on. Okay, so for all states we'll be storing the results, and whenever these states repeat themselves, we'll be using those results to avoid extra work. This will avoid extra work. And other than that, we'll be using solution of smaller subproblems to build the solution of bigger subproblems. So it is a two-step process. So this is what dynamic programming is in nutshell. Okay, and I'll be also providing a link for explaining an article what dynamic programming is. You can definitely check that out and you'll be able to understand in a much clearer way what dynamic programming is. So let's see how we'll be applying dynamic programming over this particular problem. So let's say we sort the array in descending order. Okay, so let's say you sorted the array, so it can become 1 3 2 1. Okay, so let's take this example. Earlier it was 1 2 3. You sorted it in descending order, and then now it became 3 2 1. Now you will see that if you want to find multiples of a number, that will those multiples will only be in this direction. Okay, let's say you want to find multiples of 1, then you cannot find multiples in right hand side. Let's say there were some numbers here also. Let's say negatives were also allowed, so some smaller numbers were there. So a smaller number, you know, can only divide a larger number, but a larger number cannot divide a smaller number fully. What I mean by this is 1 can divide 3 completely, but 3 cannot divide 1 completely. Okay, it will not be 0, it will be 1 only. Okay, so that's the case. That's why we are, you know, sorting this array in descending order, so that we can find all the multiples of a number. So what we were doing here in this particular thing, that we were checking all the multiples of 1, and we will be checking whichever multiple of 1 was having the longest chain that can be possible. Okay, so for every number you will be checking its multiples, and you will be seeing what is the longest chain multiple that is there. Okay, so let's define a, so you can see that the state of the dynamic programming is dependent upon only one variable. What this variable is? This variable is current number that we are visiting, or you can say the index that we are visiting in this nums array. So there is only one state variable here. Okay, so a 1D dynamic programming structure, because there is a one state variable, will be sufficient to store the results of intermediate states. Okay, so let's define a 1D dynamic programming structure. For simplicity, we will be taking the same name that we have taken in the this implementation. So let's see what we have taken. So it is nothing but, yeah, multiple chain it is. Okay, so multiple chain for a particular index will be initialized with the number that is there at this particular index. So let's say you are at the second index. Okay, so these two are having these chains. So initially your chain will be initialized with 1. Okay, so then you will be seeing whatever are the multiples of 1 that are possible there. So you will be starting from one index previous to the index of 1, which is this index, and you will be going backwards, and you will be finding longest multiple chain that can be there. So these two chains are having same length. You can pick either of them. So let's say you pick this chain, then you will append whatever was the contents of this chain to your current current numbers chain. Okay, so it will be appended like this. So this is how we will be, you know, forming a state transition equation here. So the state transition equation will be more clear in the implementation part. So let's see how we can implement this. Okay, so initially what you will be doing is, you will be first of all sorting the nums array in descending order. array or say vector, whatever you may want to call it. Let me zoom in a little bit. To find multiples of a number efficiently. As they will be before that number while we are traversing from left to right. Okay, so after sorting the given nums array, you will initialize your dynamic programming structure. So it will be a 1D dynamic programming structure, but since each index is storing a chain, so that's why we are requiring, you know, another vector that will represent a chain. Okay, so this will store max length chain for each number that can be there if we start DFS with this number as source. Okay, so for every number you will be taking maximum length multiple chains that can be there. Okay, for every number you will find max size chain of its multiples. Okay, so if you take a bigger example, so this chain was the longest among all the multiples that are there for 1. Okay, so that's why we took this chain and appended it to the chain of 1. Okay, for every number you will find the max chain of its multiples. Now once you are having that chain, you will append, and every number will have a chain initialized with itself. Okay, so you will add whatever the maximum chain you find out to this particular chain. Okay, so this if condition is doing that, then after that you are done with it, you will be storing the current chain that will be there for current number. So you will store max length multiples chain for current number that can be possible. Okay, and along that you will be tracking the size of the maximum length chain that can be there. Okay, so it is very much understood that this one will be having the chain which will be of maximum size. So among all the chains for every number that were there, you will find out the chain which was having the same length as of the max chain size, and you will be returning that chain. Okay, and that is how we will be solving this particular problem. If you are still having any doubts or any queries in general, then you may ask them in the comment section. Thank you for watching. Have a great day ahead.